Hey folks, so what we're going to look at now is we're going to look at properties of logarithms, and we're going to focus in on one of these skills that you really have to do in order to be able to do like work with discrete mathematics. It's going to come in really handy when we start working with computation and trying to figure out big O and things of that nature. And so consequently, we do need to at least have some review of our properties of logarithms. Hopefully this is a bit of a review if you have already gone through, an Algebra 2 and a college algebra or pre-calculus course as well. So we're going to start out, we've got four basic properties that we're going to work with. We'll see some examples and then we'll put some of them together. And that's kind of the idea, that's what we want to work with here. The first property we want to look at here is the addition property. So the addition property, we're going to have to kind of get a little bit of vocabulary just to remind you here. The b here is called the base of the logarithm, and that relates to the base of the exponential as well. So when we look at exponential functions, we see that the exponentials have bases, the logarithms have bases as well, and the base in the logarithm and the base of the exponential are actually the same because they're inverse functions of each other, okay? So, as you're thinking about these things, see if you can kind of put that idea together. So we have the base, okay, and then we have our argument, we have x and y, okay? So log b xy is going to equal log bx plus log by. All right, so basically what that means is that we have inside of the parentheses, or inside of what we call the argument, we're going to multiply x times y, and then what happens when we expand, okay, and what it means to expand is that you transform something from inside of the argument to outside of the argument. What we end up getting is we end up getting an addition of two separate logs with the same base though, by the way. Notice that b is the same in both cases. So I'll give you an example. Let's say, for example, I take log of 3, 6. Log 3, 6. And what I want to notice is that this is actually log 3, and that's 3 times 2. Okay? And so this will then end up equaling log base 3 times 3 plus log base 3 times 2. Notice that my bases remain the same. All right? And I just separated out the two things that were multiplied together, and I was adding separate logarithms. That's what's happening there. That's how you actually end up expanding this out. Another example, let's say, for example, I have log base k, and it's got 2k. Well, 2k is 2 times k, so this is going to end up being log base k, 2 plus log base k, k. Okay, so there's that. Now, a note here is that log base k is actually equal to 1. And in fact, this is another property where you just want to write this down. Log base b of b is going to end up equaling 1 each and every time. We'll also notice that log base b of 1 is going to end up equaling 0. So these two, we'll add in these two properties, okay, because they may actually come in handy for us a little bit later. So we've looked at expanding. Now let's go out and let's contract. Okay, so let's say, for example, I have log base 4, 3, plus log base 4, 4/3. Now I'll note that I have the same base for the logarithm, so I can use this property, this addition property, to now multiply inward. Okay, so multiply 3 times 4/3. So since the bases are the same, I can make this log base 4, 3 times 4/3, which ends up equaling log base 4 of 4. And using that property, this property right here that we had before, notice that the base and the argument, they're the same. So we're going to have this is actually equal to 1. So sometimes this makes kind of like simplifying our logarithms a lot easier, because what we can do is we can go in, take an expanded logarithm, contract it, okay, and then utilize one of our other properties in order to get some information. Take another example. We'll take log base, and let's let this be log base x. So it's an unknown. We have some kind of unknown, and we'll have log base x of k plus log base x of 1 over k. So now what we have here then, we'll notice that the bases are the same again, so we can bring the two values in and multiply k over 1 over k. And this gives me then log base x of 1. And this second property right here, that's going to tell me that that actually equals 0. And that's the addition property of logarithms. So essentially what we're doing is we're saying, okay, we've got a base. We're going to multiply xy inside of the argument. And then what that allows us to do is to expand into an addition of separate logs. So we had an addition property. Now what we want is we actually want to utilize the subtraction property. So the subtraction property has inside of the argument, it's going to have a division. It's got x divided by y in this case. And what will happen is that the numerator will be our first log, and then we'll subtract the log of the denominator, log b base x minus log by. And that actually ends up being our subtraction property. Very similar to the addition property. So let's try out a couple. Let's say, for example, I have log base 5, and it's got log base 5, and we'll have it be 5/3. So log base 5, 5/3, and that'll be then log base 5, because the base remains the same, log base 5 of 5, minus log base 5 of 3. So bases are the same, we just separate numerator minus denominator. And so this will end up equaling, well, log base 5, if you remember, that's going to end up being, log base 5 of 5 is going to end up being 1 minus log base 5 of 3. Let's try another one. Let's say, for example, I have log base x of 2x over y. So now we've got a quotient, so we'll take log base x of 2x minus log base x y. And you may say to yourself, hey, look, I actually have that right there. This will end up being, that's a multiplication, so I'll take that and I'll make that log base x of 2 minus log base, or plus log base x of 2x, or excuse me, of x, minus log base x of y. And we could change this one into a 1 if we want. Make that log base x of 2 plus 1 minus log base x of y. So this is called an expansion because we're taking the argument and expanding it into two separate logarithms. Let's contract it. Let's actually bring it in. Let's take two separate logarithms, turn them into a single logarithm, and contract. So we'll now have log base 2 of 5 minus log base 2 of 2/5. And this ends up equaling now, well, what we're going to notice is we've got log base 2, and that'll be 5 divided by 2/5. And this actually ends up being log base 2 of, this will be 25 over 2 if you just invert multiply. Okay, there we are. We could have, by the way, we could have gone in and, in fact, expanded this out. And if we wanted to do that, what we get is we would have gotten log base 2 of 5 minus, and what I'll do is I'll put these in parentheses because we're going to subtract out the whole thing. So it's going to be log base 2 of 2 minus, minus log base 2 of 5. And so what we get here is, and this is really important because notice the negative and the negative, right? We got the two negatives. We're going to end up with log base 2 of 5 minus log base 2 of 2, which is a 1, plus log base 2 of 5. So those signs actually really make a big difference. Let's do one more. Let's say, for example, I have log base k of x over y. So this is going to be log base k of x minus log base k of y. And that's our expansion. Let's actually do one more contraction then. We'll take log base k of 2x plus 1 minus log base k of 3y minus 2. And what we get then is we get log base k of the numerator will be 2x plus 1, and the denominator will be 3y minus 2. And there is our subtraction property. So the subtraction property, what we see here is we're going to, if we have a quotient inside of the argument there, we can separate that out into two separate logarithms with the log, same base, of the numerator minus the log of the base of the denominator. And that gives us our subtraction property. Next we have our multiplication property. And what's going to happen here is we've got log base b of x to the y. And you'll notice inside of the argument, inside of those parentheses, we've got x to the yth power. Okay? What will happen here is we're going to actually take that power and we're going to bring it out to the front of our logarithm. We're going to make it y log b of x. Okay? And so that's going to be the expansion. So for example, if I have, I've got log base 5 and log base 5 of 125. We're going to see this actually quite a lot, and this is one of the great ways to go through and like simplify these things. You're going to notice that this is actually log base 5 of 5 cubed. 5 cubed equals 125. We'll use our property, our multiplication property, to make this now 3 log 5 of 5. Okay, so notice that our 3 comes over to the front, right? The 5 stays in the middle. And so we end up now, this is, if you remember, that's equal to 1. So this is 3 times 1. So that ends up equaling 3. Another example. Let's say, for example, I've got log base k of 5 to the k. Well, when we expand it, the k will come out to the front. This becomes k log k 5. And that's a, kind of pretty simple, straightforward one. Let's take another example. Let's say, for example, we'll do another one of these. We've got log base 6, 36. You want to notice, and it's actually kind of really handy if you have, at least you can kind of think in terms of powers when you're working with logarithms. You can start to notice ways to simplify these things. Well, log base 6 of 36, we know that 36 is 6 squared. So this is log base 6 of 6 squared. So this ends up being 2 log 6 of 6. And that is, again, 2 times 1, which equals 2. Okay? Now, we expanded. We can actually go in and, in fact, contract. So let's say, for example, I've got 8 log 3 to the k. This will end up equaling log 3 to the k, log 3k to the 8th. So the multiplication then becomes a power. There we are. Okay? And that is one of our contractions. Now let's take a look at change of base. All right, so change of base is the last property that we're going to look at inside of this mini lesson. And so we'll start out with, we've got log base c of x. And you'll notice that the base here is c. And then what we're going to do is we're going to change the base to log base b. And how we do that is we're going to have log base b of x divided by log base b of c. And that's how that works. So let's say, for example, I have something along the lines of this. Let's say I have log base 5 of 2. Okay? And I want to change it to log base 2 because this actually might make things a little bit easier to see, or I might be able to simplify. So this is now log base 2 of 2. And then we'll divide it by log base 2 of 5. So the base goes on the bottom. Base on the bottom. And then the argument on the top. And there we go. And so if we simplify this even further, we end up with 1 divided by log base 2 of 5. Okay, which is great. There it is. Let's say, for example, we now have log base 5 of k plus 1. And I want to change it to log base 10 for whatever reason. Sometimes log base 10 is really handy because we have calculators that run log base 10. So we change this to log base 10. It's going to be log base 10 of k plus 1 divided by log base 10 of 5. So the base on the bottom and the argument on the top. And that's how we actually use change of base. Sometimes we're going to do this for something like the natural logs, because natural log is also another one where we one, it's a very common kind of logarithm. It shows up a lot, very, very handy in a lot of applications. And then also, too, your calculator actually has natural logs on it, so you can actually go through and do calculation this way. So let's say, for example, I have now log base 8 of e to the 5th. Okay, so I've got log base 8 of e to the 5th. And we'll actually do a couple things with this. First, I'm going to change this. I'm going to bring out that 5. So it's going to be 5 log base 8 of e. Okay, and then I'll change my base to natural log. Natural log is log base e. That's natural log. So this becomes 5 times, and be sure that you're going to put these in parentheses. It's going to be 5 times log base e of e divided by log base e of 8. And the way you're going to see that is 5 times natural log of e divided by the natural log of 8. One other thing that we might want to get, just in case you don't know that this is the case, the natural log of e, so this is a little note, is equal to 1. So what we've done here is we've taken 5 times 1 over natural log of 8. And there we are. And that is the expansion using the change of base. We're not frequently going to do the change of base in the opposite direction, just because it tends to be, it just doesn't happen that often. The change of base is one that we utilize in order to do computation. It's also one that we use because you'll have like built-in calculators inside your computers and the like, and they only use log base 10 or natural log. So that's why we're going to use our change of base. So just to utilize do some mixed practice now, let's say, for example, that I've got something along the lines of log base 5, okay, to the 200. Log base 5 of 200. And one of the things that I want to think about is I want to think, oh, you know what? I actually have a power of 5 in there. Let's say I want to expand that out in some way. So I'm going to do some expansion. I'm going to make this log base 5, and I'm going to note that it's going to be 25 times 8. Okay, so log base 5, 25 times 8. And that equals then log base 5 of 5 squared times 8. So this is just something to kind of look out for as you're working. It's a good thing to know when you're working with logarithms. If I can get something down to like the base inside of my argument, I can actually expand out quite a lot and do a lot of simplification. So this is now equal to, and we'll first use our addition property. So we've got log base 5 of 5 squared plus log base 5 of 8. And we'll make this equal to then 2 log 5, or log base 5 of 5, plus log base 5 of 8. If you remember, log base 5 of 5 is equal to 1, so this ends up becoming 2 times 1 plus log by 5 of 8, or 2 plus log 5, 8. And there we go. Let's try another one. Let's say, for example, that what I've got here is I've got log base k of 6 to the k plus 2. So now I've got a couple of different bases, okay? So what I'm going to do here is I'll pull out k plus 2. So now I have k plus 2 times log base k of 6 to the k, which equals k plus 2, and I can actually do this again. I can pull the k out again, so times k to log base k of 6. So you can actually go through and utilize your properties multiple times. Okay? Let's say, for example, we want to change to natural log. And so we'll do something where we're going to be doing a change of base to natural log. Let's say that what we have now is we have log base 6 of 2e minus 1 to the kth power. This now becomes log k times log base 6 of 2e minus 1. And now we'll use a change of base, okay? And the change of base is now going to be k times, and the whole thing, it'll be log base e of 2e minus 1 divided by log base e of 6. Log base e, remember, is a natural log, so this is k, and it's natural log of 2e minus 1 divided by natural log of 6. So we can actually intersperse our different properties and work with different properties at different times. I'll tell you a couple things that as I was working here, I thought to myself first, before I did my change of base, was to actually bring out that k. Okay, to bring out the k. There are different ways to go about approaching, right, multi-step logarithm problems or even multi-step exponential problems. But I think probably the first thing to do is to utilize the multiplication property. Okay, utilize the multiplication property first. Then I use change of base, and then after that, I'm going to go out and I'm going to do either my multiplication or my subtraction property. Okay, and that just kind of helps me to stay ordered. Is this an exact order of operations? No, not really. But first, right, I like to use the multiplication property, or excuse me, yeah, multiplication property. Then change of base. Then addition or subtraction. And that's just generally a guideline that I use. It's not necessarily something that you have to do. One thing you have to remember, though, is that if you go in and you multiply by, say, for example, in this case, k, and you multiply, and then you go change of base, that k is actually being multiplied by both the top and the bottom in the change of base, because you're actually multiplying that by the entire logarithm, log 6 of 2e minus 1. Right? So really important that when you actually do go out and expand something or contract something, that you are keeping any kind of multiplication or raising to a power, okay, over the entire log. All right? And so those are just some things to kind of like remember as you're going through and doing logarithms. So I hope this helps. Get a little bit of practice in, and you should be able to do great with this.